So what if I have 1 mole of a gas at this temperature and pressure? How do I find the volume? Well, I just plug into PivNert, like so, and in this case I solve, and the volume is 22.4 liters. Now notice that I did that without knowing what the gas was. In other words, this gas could have been methane gas or oxygen gas or hydrogen gas. It doesn't matter in the equation as long as it's 1 mole. Okay, so that means that this is true for any gas that obeys this equation. And remember, we use the word ideal for gases that obey this equation, for which those assumptions we made are true. The assumptions about the particles being really far apart and so forth. So you need to remember this number because it comes in handy. This temperature and pressure are defined as STP. So here's the volume at STP. STP stands for standard temperature and pressure. Sometimes we just call that standard conditions. So we'll say oxygen gas at standard conditions, and you need to know that that means 0 C and 1 atmosphere. And actually this is exact. These numbers are exact. We can take that a little further and say that it doesn't matter which temperature and pressure it is, as long as you have 2 gases that obey that law, equal volumes will have equal numbers of particles. Another way to say that is these volumes are the same as long as the 2 gases are at the same temperature and pressure, then the number of particles inside are the same. We can also say, well, let's go ahead and put this in. Let's see. Another way to say that is they're equally spaced. So the masses don't have to be the same because this one has much larger particles in that volume. So the masses can be different. And so the same is true for the density. The 2 densities can be different. Let's consider 2 particular gases, hydrogen and helium. To know what the densities are, we need to consider the masses of the particles. In other words, the molar masses. For hydrogen, it's 2.02 grams per mole. For helium, it's 4 grams per mole. So in other words, if this is the helium and this is the hydrogen, these particles are twice the mass of those. So that means that helium is twice as dense. Because the mass is double. If we rearrange PivNert, we could get this equation, and I'm not going to derive this, but sometimes people solve for density this way. And we see that the higher the molar mass, the higher the density, and it is directly proportional. So this is kind of convenient because we could look on the periodic table and figure out a molar mass for any gas, and we can compare their densities. So oxygen, so which of these 2 is more dense? Well, it would be the CH4 is less and the oxygen is twice. So which of these two is more dense? Well, the oxygen has twice the mass, and so of these two, oxygen is 2 times as dense. That also tells you in an environment what's going to sink or float. If we had a mixture of these two, or we slowly put them into a container together, the body of the CH4 would tend to go toward the top before they got mixed. By diffusion, they would eventually get mixed.